Welcome, everyone. Look, if you're an infrastructure admin gearing up for the Nutanix NCP-MCI 7.5 exam, you are exactly where you need to be. Think of this explainer as your masterclass. As a senior systems architect myself, I'm going to set a bar today that's pretty demanding but absolutely supportive. We're diving straight into section 14.4 of the blueprint, behavioral learning and VM efficiency. Now, this isn't just about checking a box to pass a test. No, this is about really mastering how Nutanix Prism Central leverages machine learning to keep your clusters absolutely humming. We need to understand how the system flags inefficient VMs, and crucially, how it acts on that data to reclaim or rebalance resources. So grab your notebooks, get focused, and let's get to work. Okay, let's dive into this. Here is our diagnostic funnel for today, which maps perfectly to the exam's expectations. Section 1, the symptoms, why this actually matters. Section 2, the diagnosis, how to identify those inefficient VMs. Section 3, exam traps and edge cases. And finally, Section 4, the prescription, the key facts you absolutely must memorize. All right, Section 1, the symptoms, why VM efficiency matters. But before we get into the weeds of individual metrics, I really want you to take a step back. Try to look at your cluster performance as a whole. When users start complaining about a slow application, the root cause is rarely the actual hardware, right? It almost always boils down to resource misallocation. And to fix that, Prism Central relies on something called behavioral learning. This is its built-in machine learning capability that analyzes resource usage over time to monitor consumption, detect anomalies, and really guide your VM right-sizing efforts. But here's the absolutely critical takeaway for the exam: the baseline. The system needs a baseline, typically 21 days, of quietly monitoring metrics like CPU, memory, and storage I/O before it can make these critical efficiency categorizations. It literally has to learn what normal looks like first. And this brilliantly illustrates exactly what that behavioral learning produces for you every single day, the VM efficiency widget. If you're an admin, you know this is your daily operational dashboard. But it's also highly testable material. Notice those 4 distinct quadrants: over-provisioned, inactive, constrained, and bully VMs. Prism Central takes that 21-day baseline we just talked about, crunches the numbers, and buckets your problem VMs right here, so you can actually take immediate action to right-size your environment. Okay, before we break down those specific quadrants, we need to enforce some strict acronym discipline. You are going to see these terms everywhere on the exam and in the docs. First up, VM, virtual machine. Pretty basic. We all know that one. Next is ADS, which stands for Acropolis Dynamic Scheduling. ADS is basically your cluster's background rebalancing engine. It monitors host-wide pressure and handles migrating VMs to keep things stable. And finally, NIVA, the Nutanix Intelligent Virtual Agent. Now, if you've been around the block with older AOS versions, you probably know this as Intelligent Assist. But starting with PC.7.3.1, it was officially rebranded to NIVA. It's your go-to for in-product recommendations. Keep these definitions locked in your brain so there's zero confusion later on. Moving right along to Section 2, the diagnosis, identifying inefficient VMs. I need you to pay super close attention here because we're about to look at the specific afflictions a virtual machine can actually suffer from. The exam is absolutely going to throw VM metrics at you and expect you to accurately diagnose the problem using one of these 4 profiles. So let's walk through them smoothly. First, you have the bully VM. This one consumes way too many resources and literally starves its neighbors. Next up, the constrained VM. This poor thing doesn't have enough resources to handle its workload, which creates massive performance bottlenecks. Then, on the flip side, we have the over-provisioned VM. This one is drastically oversized, just hoarding and wasting resources it never even uses. And lastly, the inactive VM, which is either completely dead or doing so little it's practically a zombie. The entire goal of VM right-sizing is to identify these profiles, take resources out of wasteful states, like over-provisioned or inactive, and shift them over to productive states to relieve those constrained VMs. Let's actually contrast 2 of these directly. A constrained VM is resource-starved. Based on its past 21 days, it is consistently hitting high utilization. For example, a severe constraint is flagged when CPU or memory usage blows past 95%. It's struggling, and it's dragging down the application. An over-provisioned VM, though, that's a resource hoarder. You've allocated vast amounts of CPU and memory to it, but over the last 21 days, its utilization has been sitting below 50%, or even below 20% for severe cases. It is just sitting there, tying up vital cluster capacity while doing next to nothing. Now let's look at a concrete example that we've all felt as a real-world pain point: the bully VM. A VM gets labeled a bully when it exhibits very specific aggressive behaviors for over an hour. For instance, if a VM has a CPU ready time greater than 5%, what that actually means is the VM is aggressively cutting the line. It's waiting for compute cycles and starving its neighbors in the process, which causes very real, noticeable lag for your end users. The system also flags a bully if the memory swap rate is greater than 0 kbps, or if the host Stargate CPU usage spikes over 85%. If you see these metrics sustained for more than an hour, you've absolutely got a bully degrading your overall cluster performance. Our second concrete example is the inactive VM, and you need to know there are two very distinct flavors here. The first is a dead VM. That one is super straightforward. It's just a VM that's been totally powered off for at least 30 days. But the second type, the zombie VM, that one is incredibly dangerous to your cluster's efficiency. A zombie VM is powered on, the OS is running, but it has very few read or write IOs and minimal network traffic for 21 days straight. It is just quietly bleeding your background memory and CPU cycles without doing any actual productive work. Identifying and deleting these zombies is hands down the fastest way to instantly reclaim wasted host capacity. So once we actually diagnose all these inefficiencies, how does the Nutanix AHV hypervisor fix the imbalance? Let's detail the underlying why of resource reclamation, especially when memory overcommit is turned on. Step 1, obviously, is identifying the pressure. Step 2 is where the real magic happens, cooperative memory ballooning. AHV basically talks to the VirtIO driver installed inside the guest OS and politely asks it to give back memory pages it isn't actively using. This is AHV's preferred minimal impact method. It's only if ballooning isn't enough, or if we have severe cluster-level pressure, that we move to step 3. That's when our buddy ADS steps in to either reduce overcommit, initiate swapping, or fully migrate VMs to other hosts to rebalance the cluster. All right, let's shift gears into a highly focused exam prep load. Section 3, exam traps and edge cases. Write this down. Here is your exam tip. The test writers love to see if you know what happens when these rules collide. Consider this specific logical conflict. What happens if a VM has been sitting there for 21 days with CPU usage below 20%? That qualifies it as severely overprovisioned, right? But what if it also has practically zero network traffic and disk I/O, which qualifies it as a zombie or an inactive VM? Take a second. How does Prism Central categorize that? Here is the definitive answer. The absolute crucial point you need to know is the inactive category takes precedence over the overprovisioned category. If a VM is classified as inactive, it will never be marked as overprovisioned. And honestly, that makes perfect logical sense. You do not want to waste your time trying to carefully right-size the CPU and memory of a VM that's basically acting like a zombie. You just want to delete the thing. Next up, let's look at time frame traps. The exam is absolutely going to try to trip you up on how many days the behavioral learning engine needs to make a decision. Don't rush this. Let's make the distinction crystal clear. For almost everything, constrained VMs, over-provisioned VMs, and zombie VMs, the system requires exactly 21 days of historical data to establish that baseline band of normal behavior. However, for a dead VM, the system waits longer. A VM has to be completely powered off for a full 30 days before it gets officially categorized as dead. Keep those two numbers firmly separated in your notes. And here is another classic exam trap, this time regarding the math behind behavioral learning. When the system looks at the hourly averages of metrics to make these decisions, it uses completely different percentiles depending on the category. To flag a constrained VM, it looks at the 95th percentile of those hourly averages. But to flag an over-provisioned VM, it demands a much stricter confidence interval, the 99.5th percentile. The logic here is that the system wants to be incredibly, statistically certain a VM truly doesn't need its resources before recommending you take them away. Which brings us to our final review section. Section 4, the prescription. Consider this next slide your ultimate cheat sheet. You are going to want to mentally screenshot this one. Let's do a steady, rapid-fire rundown of the absolute must-memorize facts required to pass the NCP-MCI 7.5 exam. Number 1. A bully VM is flagged by metrics like greater than 5% CPU ready time sustained for over 1 hour. Number 2. A constrained VM is flagged when CPU or memory usage is greater than 90% over a 21-day baseline. Number 3. An over-provisioned VM is flagged when CPU or memory usage is less than 50% over a 21-day baseline. And number 4, the golden rule. Never forget the precedence rule. Inactive always trumps over-provisioned. So, now that you understand exactly how the behavioral learning engine analyzes, categorizes, and reclaims your resources, I want to leave you with a final provocative thought. How many zombie and bully VMs are secretly draining your cluster's performance runway right now? Seriously, I highly recommend you log into your own Prism Central environment today, pull up that VM efficiency widget, and see exactly what the machine learning has uncovered in your own infrastructure. Thank you so much for joining me for this explainer. Study hard and good luck crushing that NCP MCI certification.